So today we're going to be looking at finding the net force on a charge when we've got three other charges surrounding it. Now we're going to look at this in a linear fashion, all right, where they're all in the same plane and same line. So if you look at this image here, I've listed out my charges. I've got a positive 3 microcoulombs, a negative 2 microcoulombs, a positive 6 microcoulombs, and a positive 12 microcoulombs, and the distances are listed here. We are going to try to figure out what is the net force, okay? So we're going to try to figure out what's the net force, or the sum of all the forces on F2. So that's our goal. So to do this, we need to figure out each individual force acting on this. So what we're going to do is figure out between 1 and 2 what's the force, between 3 and 2, and between 4 and 2. So we list out our variables. We have all of our charges already listed out over here, our base equations up here, and our distances are here. Now we have to make a couple changes. First, whenever we have micro, we have to make that times 10 to the negative 6th. So for all of these numbers, we're going to add times 10 to the negative 6th. In centimeters, for our radius, has to be in meters. All right, so we have to make those conversions. So distance needs to be in meters, and microcoulombs needs to be converted to coulombs for our charge. So we will go like this, F1 on 2. Now K is a constant. It's 9 times 10 to the 9th meters squared times newtons over coulombs squared. So for 1 on 2, now we're doing the absolute values of the charges. We don't care positive or negative. And we put that multiplied times 2 times 10 to the negative 6 and 3 times 10 to the negative 6 all over the radius of 0.05 meters squared. I guess I didn't need to really write that there. And that's going to give me 22 newtons of force. And we're not concerned with direction yet. We'll get to that in a minute. Then we have the force of 3 on 2, which, same equation, 9 times 10 to the 9th, times 2 times 10 to the negative 6th, times 6 times 10 to the negative 6, all over the distance of 0.3 squared, which is going to equal 1.2 newtons. And the last one, F4 on 2, equal to 9 times 10 to the 9th, times 2 times 10 to the negative 6th, times 2 times 10 to the negative 6th, all of that over 0.4 squared. Now I got 0.4 because the distance between Q2 and Q3 is 0.3 meters, and between between Q3 and Q4 is 0.1 meters. So the total distance between Q2 and Q4 is 0.4 meters. So I got to add these two distances together. All right, so we need to add these two distances together to get that value, and that's going to equal 1.4 newtons. That's supposed to be a 12 there. So that's 1.4 newtons. So now we have to decide for the net force, are all these getting added together or subtracted? So Q1 is going to pull Q2 to the left. So this one's going to go to the left. So that's going to make that go to the left. 3 is going to make it go to the right, and 4 is going to make it go to the right. So 3 and 4 are going to get added together, and that's going to be a value of 2.6. And then we got 22 going to the left. So the sum of all my forces here is equal to negative 22 plus 1.2 plus 1.4. Move this out of the way there. And our net force is going to end up being 19 newtons with sig figs. And it'll be to the left, or a negative value. That just looks like continuation, so let's make that a negative. Alright, so the sum of all the forces on 2 is negative 19 newtons. I hope this helps.